Good afternoon, everyone, and thank you for introducing me, Sai, and inviting me here. So I've been working in this area for almost now 2 decades, I would say. I started with machine learning in AI in image processing, and then the deep learning came, which completely transformed the image processing, which was the new AI. And I teach advanced level, graduate level courses in machine learning and artificial intelligence at IIT Bombay. And I work very closely with many industries on various aspects of applications of AI for manufacturing. There is a huge gap in understanding as to what really AI is. And usually there are 2 schools of thought which I have come across. There are people who just completely outright reject AI. They say AI is actually nothing. It's not going to do anything, it's just a hype. And then there is another school of thought of people who say, oh, well, AI can do everything. And the reality is they both are wrong. And that is one of the key aspects which I want you to understand. And it's more complex than just a simple one school of thought or the other school of thought. So the term artificial intelligence is older than any one of us in this room. It's like 75 plus years old. And I don't think anyone is 75 years old. Probably I'm the oldest guy here, but that's all right. So it started in 50s, before 50s, and AI became a term well known in science fictions in 50s. And there are lots of novels which AI could do pretty much everything in those science fictions. And people thought that's going to happen. But it didn't happen. Multiple decades happened, nothing happened. And then in 70s, towards the end of 70s and 80s, there came another aspect of AI, which is known as machine learning, where the machines were now being asked to learn themselves rather than them to be programmed. And that was one major step in the growth of artificial intelligence, where machines were not being programmed anymore by programmers, but were given generic instructions, and then they used to learn the rest of it from data. And that's where data became very important. But that was 1980s. 80s, 90s, 2000. Machine learning was struggling. It was able to do a lot of stuff, but then it used to saturate. So if you see the performance of a conventional machine learning model, it improves very quickly in the beginning as you feed more data to it. But once you give more data beyond a critical point, the performance tapers down. These machine learning models could never, ever compete with human intelligence. They were no match to human intelligence. The only thing which was there is that for that initial performance, they could be multiplied. So you have 2 people, 10 people, but you could deploy 100 models. So there was a multiplicative factor, but the performance of each of them were far inferior to that of humans. And this became such a long drawn process that people decided and thought that it's not possible for AI to ever challenge human intelligence. But that's when something happened which changed the entire world. And that was in 1989. A mathematician, and AI is nothing but maths, let me just tell you, it's actually just maths, pure maths, applied in many different manners, but it's just the final language of AI is maths, and probably that's what is the language of universe itself. And that's when a mathematician came up with a very unique theorem, the UAT, the Universal Approximation Theorem. And this was probably the biggest, I would say, turning point in the journey of AI. He proved that it's possible to have functions which can approximate any function in the universe to any level of approximation. You can model any phenomena of the universe to any level of approximation or any level of significance using these universal approximation functions. And this is known as Universal Approximation Theorem. This was very celebrated. People thought this is it. This was next to God. God could do everything. This could do everything as precise as you want. You could reach as close to the reality as you want for anything in the world, in the universe. And that's why the name was given. Mathematicians are not known to give these profound names, but this was called Universal Approximation Theorem. It could approximate anything in the universe. However, this was a mathematically proven theorem. One could not train these universal approximate functions to learn. They were extremely tough to learn. You could not train them. And time passed on, and almost 2 decades passed, and people could not train these machine learning universal approximate functions. And then they realized that probably this is one of those mathematically possible to be proved, but practically impossible to be applied. So these are one of those tricks, you have those riddles which are just a mathematical riddle. It cannot ever be realized in reality. And people literally gave up hope. They thought it's not possible. They kept looking at conventional machine learning models, tried improving it. Lots of advancements happened. Very complex functions like support vector machines with non-linear kernels came. Some real good advancement happened in the conventional machine learning, but the universal approximate functions could not be trained. And that all changed in the first decade of this millennia. There were a lot of researchers who could not train the machine learning algorithm because it was just too complex, and that's when they realized that they're using the wrong hardware for that. They're training this on a computer. Computer is a general purpose machine. It's not meant for crunching so complex numbers as demanded by a universal approximate function. They need to have a different hardware. And then they soon realized that there is such a hardware already existing. This hardware is known as graphical processing unit, GPUs. GPUs were big business for the gaming industry. PlayStations, Nintendo, they were using these GPUs for youngsters to play fast action games on their gaming consoles. These GPUs were machines which were meant for very fast matrix transformations. They used to rotate images in 3D on any axis. They could do any matrix calculation without going to CPU. They never used the computer. They were running everything on the graphics card itself. So the CPU was not doing anything. It used to just say rotate about this axis by 5 degrees. But the data is sitting with GPU. The calculation is sitting with GPU, just gets one instruction of 5 bits. And that's it, what the CPU does, and then the GPU work. And they said, oh wow, such a powerful system is there. Most of the training which is required for universal approximation functions is actually matrix multiplications and matrix inversions. So why can't we rig? So the first universal approximate function was trained by rigging a hardware meant for gaming. And this happened in 2010. One of the major works, it started happening a little before, but 2010 it was formally established that you can rig a hardware and create a trained universal approximate function. These are known as deep neural networks, and that's where the deep learning started. The first most popular deep network which still is a standard for comparison is known as AlexNet. That unambiguously established that this is the process going forward. And suddenly a company which used to say toys, gaming stations, became an AI company. NVIDIA. Anyone from NVIDIA here? Good. So NVIDIA suddenly realized that they had been making the most powerful AI machines, but they were selling it to the gamers. And then realized, oops, we did not know that we had that power which the world needed. And today, that is the world's largest AI hardware manufacturer. Others are trying to just do the catch-up. All these other companies are just trying to do the catch-up. And NVIDIA has become the name synonymous to deep learning. Now, deep learning has potential like nothing ever seen before. You feed it more data, and it keeps growing. It keeps growing. It's literally having no end. As long as you have data, and as long as you have compute power, you could make it grow, and the human intelligence may be somewhere there. It has already surpassed human intelligence, and it's probably going to challenge the intelligence of God, maybe. It has no end. But the God is probably more clever than deep learning is. So we don't have infinite data, and we don't have infinite power, and that's the only thing which is stopping it from growing. If you give it more data, you give it more compute, it can grow and become anything and everything. And this is what I call as the Cambrian explosion. This is literally a turning point in the history of humanity, not just AI. Humans will never be the same again. Cambrian explosion was a geological event which happened more than 500 million years back, 530 million years back. The earth had life on it. It was evolving from one species to the next species to the third species in a very slow manner. But suddenly we have geological evidence that about 530 million years back, suddenly something happened. And the life started evolving orders of magnitude faster. Suddenly we had lots of different species of animals, plants. We do not know why that happened. But that acceleration is what is known as Cambrian explosion. And after that, there was no turning back. The species kept growing more intelligent and advanced. And then apes were formed. Then Homo sapiens were formed. And finally, Homo sapiens sapiens, we humans were born. So we are a direct result of this Cambrian explosion, which happened, of course, 500 plus million years back. But in the world of AI, that happened in 2010. And those who know and remember, who have been in this area, that 2010, prior to 2010, there were journals on pattern recognition, whole entire image processing journals, advanced journals of pattern recognition. I have published, I have worked on them. They suddenly became useless because you had such a powerful tool that they all looked like toys, kids in front of this deep learning universal approximation function. So now this is the backdrop of what really AI is. And it is since 2010 is that we are really living in an AI era. And now this artificial intelligence is growing by the weeks. In about 6 to 8 weeks, in 2 months, it almost becomes 1.5 times more powerful. This is unimaginable. This is a geometric progression which really has only one end, which is the singularity. It eventually will become so enormous that it will be beyond anyone's comprehension, as long as we have data and compute power.